Hey guys, we are going to be continuing with our mole unit this week and then heading into stoichiometry. Um, the first thing that we're going to do, so we've learned all of our basic conversions, but other things with mole is actually figuring out the formulas and stuff like that. One thing we're going to be dealing with is percent composition of a compound. This is going to look at the percentage by mass of what percentage of this compound is sodium or what percentage of this compound is chlorine. So it looks at the relative amounts of elements in a compound. Um, and to find percent by mass, you're going to have the grams of the element divided by the mass in grams of the compound, so your overall molar mass, and then times 100 to make it a percent. And if it just wants the percent composition of the entire compound, you have to do this for every single substance in that compound. If it's only asking for a specific element, you only have to do this for that specific element. Now note, if you're doing this for everything in the compound, your percentages should add up to equal about 100. And if it's 99.5, that's okay. But if you get like 95%, that's a little too far off, so you would need to check your math. Let's look at one way that we're going to see these problems. So you may be given a problem, and it says when you have a 13.60 gram sample of a compound that contains only magnesium and oxygen that's decomposed, 5.40 grams of oxygen is obtained, and it wants to know the percent composition of this compound. So yet again, it noted percent composition of the compound, so you will have to do every element in that compound. And here you were given the compound's mass, and then given the mass of one of the elements that was collected after it was decomposed. So in these type of problems, you're given the masses that you need to plug in. You don't actually have to figure out the masses of different substances. So I like to set these up and account for my elements. So our compound has magnesium and oxygen. So we're going to be doing two of these percent composition problems. And remember, it's the element over the compound and then times 100. So for looking at what was given, it said we have a 13.60 sample gram of a compound. So that is our compound mass. So that's on the bottom for both substances. It also told us that 5.40 grams of oxygen is obtained. So that's going to be our mass of oxygen, so our element mass. So that one we know everything for. However, it did not tell us the mass of magnesium, but it gave us enough information to figure it out, because if the compound mass is 13.60 and 5.4 of that is oxygen, if you subtract them, you know that 8.20 is the magnesium. So if it doesn't give you the masses of everything, you can simply subtract them to find what's missing. So now we know all of our information for both substances. We can put this in the calculator. So 8.20 divided by 13.60 times 100 to make it a percent. And for these, you can use sig figs, but with percentages, you normally have at least one decimal point. If you want to do this based off of sig figs, 5.40 only has 3 digits, so I would round my answer to 3 digits. So that is 60.3% magnesium. And then do the same for oxygen. You can kind of guess what oxygen is, but it's always good to double check your math. That way you know if you plugged in a wrong number somewhere, they will not add up to equal 100. So if you do the 5.4 divided by 13.6 times 100, we get that the mass of oxygen is 39.7% of the compound. And if you want to double check, those do add up to equal 100. So that would be my answer for this question. Because it wanted the percent composition of the compound, I need both elements in that compound. Let's look at another problem. When a 14.2 gram sample of mercury 2 oxide is decomposed into its elements by heating, 13.2 grams of mercury is obtained. What is the percent composition of the compound? So yet again, it wants the percent composition of the compound, so we would need to do this for every substance. So here we have mercury and we have oxygen. It tells us that our compound sample is 14.2 grams, so that's going to be the mass on the bottom for both problems. It tells us that 13.2 grams is mercury, so that's the mass of our mercury up top. That means to find the mass of oxygen, we would subtract them. So there will be 1 gram of oxygen that's obtained. And remember, we have to multiply by 100 to find our percentage. So for mercury, we have 13.2 divided by 14.2 times 100. Sorry, that looks like a 6, but it's 100. All of our numbers were to 3 digits, so we'll round to 3 digits. So that will be, it's 92.95%. So when we round up, it will be 93.0% mercury. We can guess the oxygen will be 7, but we're going to guess, or we're actually going to calculate it. So 1 divided by 14.2 times 100. So it's 7.04% if we go to 3 digits. So that adds up to be 100.04, or roughly 100. So it's okay if you're a little above 100 or a little below 100, as long as you're kind of in the ballpark. Let's go on to another way that you're going to see these. Sometimes, so in the previous examples, you were actually given the masses to plug in. Sometimes you will just be given the formula, and you're going to have to use molar mass and the masses on the periodic table to find the percent composition. This is going to be a little bit harder. So we are going to have to use the formula and the subscripts to find those masses that need to be plugged into percent composition. But it's still going to be the same formula of the element mass over the compound mass times 100. My A looks like a U. So we're still using the same overall formula, but the problem is going to be presented slightly differently. So let's look at one of these. So we have propane, those should be subscripts, which is C8H8, is one of the compounds obtained from petroleum. We want to find the percent composition of propane. So we were not given any of the masses, we were only given the formula. So in that case, you would need to use the masses off the periodic table. So we can go ahead and find molar mass. So we have 8 carbons and carbon is 12.01. Add to that 8 hydrogens. Hydrogen is 1.008. Oops. And when we put this in the calculator, we get an overall molar mass of 104.144. Remember, that's grams per mole. So that is going to be our compound mass that is going to go on the bottom for everything. So propane, we only have carbon and we only have hydrogen. So those are going to be our two problems. So that 104.144 is our compound mass for both that will go on the bottom. Now for our element mass, you can actually take the pieces from where we calculated molar mass, and that can be done as your element mass, because you do have to take into account how many particles of that element are going to be in that compound. So the mass for carbon is going to be 8 times 12.01. Now you can punch that in the calculator and get the actual number if you prefer. It's really a personal preference. For hydrogen, that top number is going to be 8 times 1.008. And yet again, you can punch that in the calculator and figure out the actual number value if you would like. But we're going to punch this in the same, the 8 times 12.01, or the 96.08 if you figured out what it is, divided by 104.144, and times 100 to make it a percent. And because we were not given original numbers to know how many sig figs to use, sig figs do not matter in here. But I would normally keep at least one decimal point. So this is 92.3% carbon. And we can assume that hydrogen is going to be about 7.7, but let's double check. So 8 times 1.008, or 8.064 if you figured out what the mass is, divided by 104.144 times 100 to make it a percentage, is 7.7% hydrogen. And that does add up to equal 100, so we're good to go. Let's look at another problem. I'm going to skip to one that has more than two substances, because this is possible. Let me see if I have another example. No. So this will be our last example. So we're going to find the percent composition of sodium hydrogen sulfate. The formula is NaHSO4. That 4 should be a subscript. Oops, my alignment's off. I apologize. We're going to ignore that. Alright, so to calculate this, we first need to find our molar mass. So set that up as we have done before. So sodium, there's only one of them, and it's 22.99. Add to that our hydrogen, there's only one of them, so that's the 1.008. Add to that sulfur, which is 32.07, since there's only one of them. And then our oxygens, we have 4 of them, and they are 16 apiece. So if we put that in the calculator, our molar mass is equal to 120.068. And yet again, it wants the percent composition of the compound, so we need to do every substance in the compound. Remember, if it only specified sodium, you would only need to do this for sodium. But since we have 4 substances, we have sodium, hydrogen, sulfur, and oxygen. And I'll scroll down if needed. So remember, we're doing the mass of the element over the mass of the compound. So for sodium, the mass of the element is 22.99 over the mass of the compound, the 120.068, times 100 to make it a percentage. You can go ahead and calculate these individually or set up all of them and then calculate. Hydrogen is going to be 1.008 over the mass of the compound, the 120.068. For sulfur, the mass of the element was 32.07 over the mass of the compound, the 120.068. And then for oxygen, we had 4 of them, so 4 times 16 over the mass of the compound, the 120.068 times 100. And then we're going to solve for each of these. And remember, even though we have more than 2 substances, they should add up to an overall total of roughly 100. I'll scroll down so you can see that bottom one. So for sodium, 22.99 divided by 120.068 times 100 to make it a percent. And remember that since we were not given numbers to reference for sig figs do not matter in this situation. I normally go to 1 decimal point. So this is going to be 19.1% sodium. We can do the same thing, excuse me, for hydrogen, the 1.008 divided by 120.068 times 100 to make it a percentage. So this is only going to be 0.8% hydrogen, which is possible because hydrogen has such a small mass. For sulfur, 32.07 divided by 120.068 times 100 to make it a percentage. It's going to be 26.7% sulfur. And then for oxygen, remember that there were 4 of them, so you have to do the 4 times the 16, or you can plug in 64. Divided by 120.068 times 100 to make it a percentage is 53.3%. And we can always double check our answer by adding the percentages together. So if you add the percentages together, we get 99.9%. So we likely did not make any mistakes there. Make sure that you're practicing these skills, and we'll pick up tomorrow with empirical formulas.